So hi, today we're going to be starting with chemistry paper 2 theory, May-June 2025 and paper 22. So this was one of the most recent papers that I could find, so let's get started with this paper. Okay, so the first question was, choose from the following salts to answer the questions. Okay, we had some salts like aluminum sulfate, barium chloride, copper nitrate, copper 2 sulfate, magnesium chloride, potassium iodide, potassium manganate VII, silver chloride, and sodium bromide. Okay, these are a bunch of salts that we're given with, and we have to choose from these options. Each salt can be used once, more than once, or not at all. State which salt is prepared using precipitation reaction. Okay, so over here you should know that precipitation reaction is used for your insoluble salts. All the insoluble salts are prepared by precipitation reaction. So let's figure it out which salts are insoluble. Okay, you should know that aluminum sulfate is soluble because all sulfates are soluble except for barium and lead. So this is soluble. Barium chloride. Many people think that barium chloride might be insoluble, but you have learned that all chlorides are soluble except lead and silver, Ag and Pb. Okay, so these two chlorides are only insoluble. So barium chloride is totally soluble. Okay, it is soluble. Only these two chlorides or halides are insoluble. Copper 2 nitrate, all nitrates are soluble. Copper sulfate is also soluble. Magnesium chloride, soluble. Potassium iodide, soluble. Potassium manganate VII, soluble. Silver chloride. Okay, so I just told you right now that all chlorides are soluble except lead and silver. So here we come with silver chloride. So this is going to be the salt we're going to prepare by precipitation. So it is going to be AgBr. Not AgBr, we should write silver chloride. Oh, why I'm writing Br? It should be AgCl. Okay, so let's write silver bromide. Okay, not bromide. Oh, why I'm confusing it with bromide? It's silver CHLORID chloride. Okay, gives a yellow flame test color. Okay, what is going to give you a yellow flame test color? Obviously that's going to be, if you've learned the flame colors, that's going to be any salt that contains sodium. Okay, because sodium gives a yellow color, so it's going to be for sure sodium bromide. Okay, so this is going to be sodium bromide. Okay, moving on. Dissolves to give a dark purple aqueous solution. Okay, it should dissolve and it should give a dark purple aqueous solution. First of all, you guys should know that all the the group 1 salts, the group 2 salts, they give colorless solutions. Okay, they give colorless solutions. So this sodium salt is going to be colorless, moreover, and many salts are going to be colorless. Group 1, this copper 2 sulfate is going to be blue in color, but purple color is a distinct color that we know for potassium manganate VII. Okay, but this is used to test for reducing agents as well, and when it's put in a reducing agent, it changes its color from purple to colorless. So this is what we know distinctly for the purple color. So it's going to be potassium manganate VII. Okay, has an aqueous solution that reacts with dilute sulfuric acid to give a white precipitate. Okay, firstly, it should have an aqueous solution that should react with dilute sulfuric acid to give a white precipitate. By white precipitate, what does the examiner mean? It means that it should be for sure an insoluble salt. Okay, a white precipitate would be created of an insoluble salt. And second important thing is that this, whatever we are making, should react with dilute sulfuric acid. Okay, so let's figure it out, that what's going to react with dilute sulfuric acid to give me a insoluble salt. Okay, one thought process over here which I can personally think of, that when it's going to react with sulfuric acid, okay, a salt that's going to react with sulfuric acid is surely going to be forming a sulfate. Okay, if for instance I react magnesium chloride with sulfuric acid, so what's going to be formed? Magnesium sulfate. So whatever salt I'm reacting with sulfuric acid is going to form a sulfate, and that sulfate is going to give me a white precipitate. That means that sulfate has to be insoluble. So I have to find a salt which contains a metal whose sulfate is insoluble, because I am forming a sulfate. Okay, so aluminum sulfate. Okay, that's itself a white, even if it reacts with sulfuric acid, it's going to form aluminum sulfate, and that's going to be the same thing. Okay, barium chloride. Okay, when I write react barium chloride, okay, with sulfuric acid, what do I get? I get barium sulfate. Let's do the reaction to know the reality. Okay, I have barium chloride, I make it react with sulfuric acid. And what do I get? I get barium sulfate. And I know for sure that barium sulfate is going to be an insoluble salt. Okay? It's going to be insoluble and it's going to give me white precipitates. So the insoluble salt that I want to give me white precipitates with dilute sulfuric acid is going to be barium chloride, because it will form barium sulfate. Okay? So over here my answer is going to be barium chloride. Okay, moving on. Has an aqueous solution that reacts with aqueous bromine. Okay, has an aqueous solution that reacts with aqueous bromine. Okay, what reacts with aqueous bromine? Can you guys remember anything from the syllabus? Okay, I know one thing for sure, that something that reacts with aqueous bromine, firstly, it is bromine is used to test for alkenes. Okay, that is the first thing I know. But over here I'm not dealing with alkenes. What I'm dealing with are salts. So I need a salt that can react with aqueous bromine. And if I think that if I react any chloride or fluoride salt with aqueous bromine, it's not gonna react. Okay, for example, if I take any chloride like magnesium chloride, for instance, okay, MgCl2, and I make it react with bromine, what do you guys think? Is it gonna react? No, this reaction is not gonna take place. Why? Because this bromine is less reactive than chlorine, so it cannot displace chlorine from its solution. Okay, but if I make this bromine react with a less reactive halogen, for instance like iodine, for example I have magnesium iodide MgI2, and I make it react with bromine, this reaction is for sure gonna take place and it's gonna form magnesium bromide. Why? Because this bromine is more reactive than this iodine, so it can displace it. So what kind of salt I am looking for that's going to react with aqueous bromine? A salt of a halogen that is less reactive than bromine, so that bromine can displace the halogen. So it has to be less reactive. It cannot be a chloride. Okay, it cannot be a chloride because bromine cannot displace the chlorine in the chloride. So what I'm going to do is I'm going to check a salt in which I have iodine or either a less reactive metal. Okay, not a metal, sorry, a non-metal. Okay, can I find an iodide? Okay, look over here, this potassium iodide, this is gonna for sure react. Okay, so the answer for this one is gonna be potassium iodide. And what is this gonna form? It's gonna form potassium bromide when it's gonna react. Okay, so you're gonna have potassium iodide, which is Ki, and when you're gonna add bromine, Br2. Sorry, 2 over here, 2 over here. Okay, and when you're going to add Br2 to it, what's going to happen? You're going to form KBr plus I2. Okay, this I2 is going to be displaced. Okay, this I2 is going to be displaced because bromine is more reactive. It's going to take the place of I in the potassium iodide. I hope you get this question. Moving on to the next one. Okay, a dilute aqueous solution of magnesium chloride is electrolyzed using graphite electrodes. Okay, what kind of solution are we dealing with over here? We're dealing with magnesium chloride and it's an aqueous solution. Okay, we have an aqueous solution of magnesium chloride and we're electrolyzing it using graphite electrodes. First thing, very important, we're not using reactive electrodes. Okay, we're using graphite electrode. That means electrodes won't take part in the reaction. So what is going to be the electrolysis of this thing? Okay, let's further read the question. Graphite has a high melting point and is inert. Okay, these are two very good qualities which make it suitable for an electrode. Explain why graphite has a high melting point. Use ideas about structure and bonding. The question is for 2 marks and they've specified how you're going to get these 2 marks by writing about the structure and bonding. What's the structure of graphite? Graphite, because it has a high melting point, it's going to have a giant covalent structure and bonding is going to be strong covalent bonds. So that is what's going to be due to the giant covalent structure, and bonding is going to be strong covalent bonds. Okay, so that's simple. 2 marks and 2 things they've given what they need. So I guess that's simple enough, that giant covalent structure and covalent bonding. Okay, state one other property of graphite that makes it suitable for use as an electrode during electrolysis. Okay, so one property of graphite that makes it suitable for an electrode. Okay, what 2 properties are we given with? We are given with 2 properties. That firstly, graphite has high melting point and it is inert. Okay, graphite has a high melting point. That means it's gonna melt at a very high point, and it is inert. These are two qualities of graphite, and the third one is gonna be its electrical conductivity. Why it's gonna be an electrical conductivity? Because look, what's gonna happen is that you are doing an electrolysis, so you have your electrodes. These are your electrodes. Okay, they are made up of graphite. What's happening in electrolysis is that your current is passing. Okay, this is your positive, this is your negative. So in order for your current, this is positive, this is negative, for your current to pass, okay, electrons are moving from the negative to the positive terminal. Electrons move from negative to positive. Okay, so wait a sec, what's going to happen at the negative terminal? Negative terminal is going to be the cathode. At cathode, what do you need? You need to reduce, so you need to add electrons. So what's going to happen? Electrons are going to move from here to here. Okay, always learn with the concepts that how electrons are going to move, because this is my anode. At anode, oxidation is going to happen. So when something's going to oxidize, it's going to lose electrons, and those lost electrons are going to travel from here to here, no matter in which direction the electrons travel. But still, for electrons to travel, you need a conductor. So you need a good conductor. So the property that's going to be used is again going to be your conductivity. Okay, because it's a good electrical conductor. Okay, predict the products of the electrolysis of dilute aqueous magnesium chloride with graphite electrodes, product at anode and cathode. To understand this, we need to write all the ions that are present in aqueous magnesium chloride. Okay, we're dealing with aqueous magnesium chloride. What type of ions do I expect in aqueous magnesium chloride? Firstly, let's look at aqueous. What do I mean by aqueous? Aqueous means that you have OH negative ions and H plus ions. Okay, aqueous means these are the ions that are present due to water. Second kind of ions that I'm gonna have is my magnesium ions, which are gonna be Mg plus ions, and my chloride ions. Okay, now I have two kind of negative ions and two kind of positive ions, and I have to decide what is going to be discharged. Okay, now there's simple rules by which we discharge objects. For metals or for positive ions, it's very easy that you check the reactivity series, and the lower you are in the reactivity series, the more chances you have of discharging. So hydrogen is below magnesium in the reactivity series, so hydrogen is for sure gonna discharge at the cathode. So over here, the winner of this race is going to be hydrogen. Why? Because it is below magnesium. Because if you look at the reactivity series, it's potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, and aluminum, carbon. Oh, it all got erased. Okay, aluminum, carbon, zinc, and then there are a few more, and then there is hydrogen, and then there is copper. Okay, so hydrogen is much below magnesium, so hydrogen is going to get discharged. Okay, the first thing. And the second thing, because it is dilute, in dilute, what's going to discharge? Obviously OH negative. Okay, chloride ions or halide ions discharge in a concentrated solution. So what's going to discharge? Hydrogen, and the product of discharge of hydroxide is going to be oxygen. Okay, whenever hydroxide discharges, what's formed? Oxygen. So product at the anode. At the anode, you have your negative ions. So product, they're asking for product. So the product is going to be oxygen. Okay, and at cathode, it's going to be hydrogen. Okay, molten aluminum oxide is electrolyzed. Okay, molten aluminum oxide. Okay, it's molten. There's no cryolite thing in it, nothing. They've told you that it's just molten. Okay, it's electrolyzed using graphite electrodes to form oxygen and aluminum. They've told you the products, that you're forming oxygen and aluminum. Construct the ionic half equation for the reaction at each electrode. Okay, this may seem tricky, but first thing we know, because it's molten aluminum chloride. So the type of ions we're dealing with are aluminum ions, which are aluminum 3+ ions, because aluminum always forms a 3+ ions, and oxygen oxide ions, which are O2 negative ions. Okay, I hope this much is clear. Okay, we have aluminum ions, we have oxide ions. Now the second thing, at the anode, what's going to go? The oxide ions. Okay, they're going to move towards the anode, so they're going to discharge. So O2 negative, okay, is going to form O2 gas. Since we're forming O2 gas, okay, to balance it out, we're going to put a 2 over here, plus, because one oxide is losing 2 electrons. Okay, one oxide is losing 2 electrons, so 2 oxides are going to lose 4 electrons. Okay, So that is the reaction at the anode. Okay, now the reaction at the cathode, we're gonna have aluminum ions. Okay, so we have aluminum ions, Al3 plus. And Al3 plus means that it is deficient of 3 electrons. So it needs 3 to discharge. So we're going to add 3 electrons to it like this, and it's going to form aluminum. So simple, I guess, and easy. Moving on. A metal object is electroplated with copper. Okay, we're electroplating. You should know, how do we do electroplating? Electroplating is what you're going to do is you're going to take a mixture. You're going to take a cathode, which is going to be negative. Okay, sorry, this is negative, and you're going to take an anode, which is positive. Okay, this is your anode. And at the cathode, you're going to put the object that's to be metal plated. For example, I want to metal plate a spoon, so my spoon is going to be my cathode, and anode is going to be the metal from which I have to metal plate. For example, I need to metal plate it with silver, so silver is going to be my anode. Okay, and the electrolyte which I take is going to be a salt of the metal that I want to electroplate, and it should be a soluble salt because I want ions moving. Okay, so for example, if I'm doing with silver, I cannot take silver chloride. That's going to be wrong. Why cannot I take silver chloride? Because it's insoluble. I need a soluble salt of silver, so I'm going to either take silver nitrate or anything else. Okay, the metal object is the cathode during the electrolysis. Okay, that's what I've just told to you guys. State the name of the substance used for the anode and for the electrolyte. Okay, since we have to electroplate the object with copper, so our anode is the metal with which we electroplate. So the anode is going to be made up of copper metal. Okay, and the electrolyte is going to be a solution of copper, a soluble salt of copper. So either you can take copper to nitrate or copper to nitrate or copper to sulfate. That is completely on you, any soluble salt of copper. Okay, so we're done with this. Moving on. The equation for the reaction between ethene and bromine is shown in figure 3.1. Okay, what's happening? That's an addition reaction. You have ethene, you've added bromine to ethene, and what's happening is that this double bond basically gets broken and one bromine attaches over here and one bromine attaches over here. But over here, you might think that what has happened, it had to attach over here, but you can just, with a single carbon, you can replace the the objects around it. Okay, these things can be replaced within a single carbon. Okay, so describe the observation when ethene gas is bubbled through aqueous bromine. I guess that's simple enough, that you have ethene gas, which is an alkene, and you have bromine. So whenever you add bromine to alkenes, what happens is that the solution goes from orange red, okay, from orange red to colorless, okay, to colorless. And why does it happen? Because look, over here this bromine is going to be orange red, and after this addition reaction, this compound, which is going to be 1,2-dibromoethane, okay, the name I don't know it's included or not, but you call it 1,2-dibromoethane, it's going to be colorless. Okay, this is orange, and this is colorless. So it goes from orange to colorless, or from orange red or red brown, reddish in color it is. You can write anything, it's going to go to colorless. Okay, next, table 3.1 shows some bond energies. Okay, we're given with the bond energy. Show by calculation that the enthalpy change for the reaction between ethene and bromine is negative 107 kilojoules per mole. Okay, now we're given 3 marks for this, and we're given with the answer. We just have to prove it. So that means we have to show each and every step. Okay, the first thing is going to be the energy that's going to be taken in. Okay, over here what's happening, bonds are being broken. This bond is going to be broken, this bond has to be broken, this bond, all bonds we have to break, and we have to break this bond as well. Okay, and this bond as well. So how many bonds are we breaking? Total 4 CH bonds. Okay, 4 CH bonds. Okay, because this is 1, this is 2, this is 3, and this is 4 CH bonds, plus 1 carbon-carbon double bond. So 1 carbon-carbon double bond. Okay, that's what we are breaking till now. And now we have to break a bromine bond as well. To get all these bonds that are on the reactant side have to be broken. Okay, we're breaking one BR bond. So 1 Br bond, Br bond. So now let's check out the bond energies for this. Okay, 4 CH bonds, so it's gonna be 4 times 410, okay, plus 1 carbon-carbon double bond plus 610. They've just given you this to not to confuse you. This is going to be used over here, okay, and 1 Br bond, which is going to be 193. So 4 times 410 plus 610 plus 193. So 4 times 410 plus 610 plus 193, that gives me 2443. So 2443 is the total energy that I basically, to break these bonds, you need to give it energy, because bond breaking is endothermic, okay. And there was a beautiful question in the MCQ paper about this thing as well. Okay, after this paper I'm just going to discuss that question with you guys as well, because in May-June 2025 in variant 12, I remember there was an MCQ question as well about this endothermic thing, and I'm going to explain it to you after this thing. But first you have to concentrate over here that you have to take in energy, and enthalpy change comes by subtracting the 2 bond energy. So it's going to be 2443, okay, 2443. You have to show all this calculation minus the energy that's going to be given out. How many Br bonds are formed? 1 and 2, okay. So 2 CBr bonds, okay, 2 times 280, okay, it's going to be 2 times 280 plus there are how many CH bonds? They're going to be 4 times CH bonds, which the value for which is 410. 4 times 410 plus carbon-carbon single bond, which is 350. So 2 times 280, okay, so 2 times 280 plus 4 times 410 plus a 360. I guess it was 360, okay, it was 350, I'm sorry for this. So it was 350 over here. So 2550, okay, so it's minus 2550. That is all the energy that's given out when bonds are formed. So 2443 minus 2550. So 2443 minus 2550, that gives me a negative 107. So equals to a negative 107, and that's the answer that I got. So I just had to show all this working that I have done over here beneath, okay. I can just copy it and paste it, because you're not gonna get marks for directly writing the answer. You have to show your working that you have done all this thing, okay. So so we have done all the working. Moving on, complete the reaction pathway diagram in figure 3.2 for the reaction between ethene and bromine. Label the reactants, products, enthalpy change, and the activation energy. Okay, where we are given 3 marks for all this. Let's do it with our full focus. First we have to label reactants, products, but first we have to realize either it's an exo or endo. Since the enthalpy change came out to be a negative, and even if we didn't figure it out, we were given in the question, even if you got this part wrong, you must get this part right, because it's given in the question that it's negative 107. That means that this is going to be an exothermic reaction, and we know that in an exothermic reaction the reactants are below and the products are sorry reactants are above, sorry, I just thought about endo, and the products have less energy, so they're going to be below, okay. So let's label them that these are the reactants, okay, and right over here we have the products. And since we have to label enthalpy change as well, so enthalpy change is always from the reactants to the products, so it's going to be from here down to here till products. So this is going to be A delta H. And now we have to label the activation energy. So how do we make the activation energy? It's going to be something like this, and for a exothermic reaction, it's from the reactants to the peak of the energy hump. So this is going to be EA. Okay, I hope that was easy. Moving on, Okay, draw a dot and cross diagram to show the electronic configuration in a molecule of ethene. Okay, we just have to draw a dot and cross diagram for a ethene molecule, show only the outer shell electrons. I guess that's easy. We just have to draw ethene. So ethene means C2H4. So we have two carbons that are bonded by double covalent bond like this, C2 and H4. It's gonna be something like this. Okay, so this is carbon, carbon. Let's draw four hydrogens. So this is 1, 2, 3, and 4. Okay, H, 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 and H. And over here we are gonna have a 1, 2, 3, and 4. Okay, that's a double bond and single carbon hydrogen bonds. Okay, so that's simple. Okay, ethanoic acid CH3COH is a member of the homologous series of carboxylic acids. Okay, we know that. Give the general formula of the series of carboxylic acids. You had to learn all the general formula before going to the exam. For alkanes, it's CnH2n plus 2. For alkenes, it's CnH2n. For carboxylic acids, it's CnH2n plus 1 COH. So CnH2n plus 1 COOH. You had to learn this, okay? And over here, the value of N is going to be 1 less than the eth thing. Okay, eth means 2. So over here, the value of C is 1, okay? One characteristic of a homologous series is that all compounds share similar chemical properties. Explain why the compound shares similar chemical properties. Because they have the same functional group, okay? The chemical properties basically depend on the functional group. Why do all alkenes react with bromine? Because all have that carbon-carbon double bond that's going to break when an bromine is going to be added. Okay, one bromine going to attach over here, one bromine going to attach over here. So that's why all alkenes react, because they have a similar functional group. So functional group determines the chemical properties of a compound. So why are all having similar chemical properties? Because they all have the same functional group. Okay, all carboxylic acids have this functional group, which makes them an acid. That's why they're going to react with a metal or a carbonate, because of this group. Okay, the equation for the reaction between calcium and dilute ethanoic acid is shown. We know calcium being a metal going to react with an acid to form salt and hydrogen gas. State the name of the compound CaCH3CO2. Okay, that's going to be easy. Look, this is your ethanoic acid, okay, and this is your calcium. So what's going to be the compound? What's going to be the salt that's going to be formed? Obviously, it's going to be calcium ethanoate, because you have taken your ethanoic acid, ethanoate, okay? If it was propanoic acid, it would be calcium propanoate. If it was butanoic acid, it would be calcium butanoate. So a sample of 1.35 grams of calcium is added to excess dilute ethanoic acid. Calculate the volume of hydrogen formed measured at room temperature and pressure. Okay, we have to calculate the volume of hydrogen. Give your answer to two significant figures. We have to be careful about this thing as well. Okay, the first thing that we're going to do is we're going to figure out the moles. Okay, we are given with the equation, and we know that 1 mole of this calcium thing going to form 1 mole of the hydrogen. Okay, 1 mole of calcium going to form 1 mole of hydrogen. So if somehow we find the moles of calcium by the mass, we can find the moles of hydrogen. So how many moles of calcium do we have? Simple formula, moles equals to mass upon mr. Okay, moles is going to be equal to mass of calcium, which is 1.35. The mr of calcium is going to be 40. So 1.35 divided by 40. 1.35 divided by 40 is going to give me this answer, which I'm going to copy and paste. So here I have my moles of calcium. Okay, so these are the moles of calcium that I got. Okay, so what's next? The next thing that I have to figure out is that I have the moles. 0.03375. 0.03375. Acha. I have the moles of calcium and these are the moles of hydrogen as well. So now I just have to apply the formula for volume to get the volume. So volume equals to, not this formula, mole equals to volume upon, because I need in dm cube, it's going to be only 24. If I need it in cm cube, it would be 24,000. So moles I have, which are 0.03375. I'm going to multiply it with 24 to get the volume. So whatever this number is multiplied by 24, and I get 0.81. 0.81. And now, since I have to give my answer in two significant figures, these are already two significant figures, okay? So because this 0 is not significant, this 8 and 1 are two significant figures. So what's going to be my final answer? It's going to be 0.81, okay? Next, this question, I guess this was the most challenging question that was, found extremely confusing by many people. They didn't know how to make vinegar, because I guess the major reason for confusion in this question was not reading the syllabus properly. In syllabus, it's clearly mentioned. Okay, dilute ethanoic acid is a component of vinegar. Describe the manufacture of vinegar. Look, read the syllabus, okay? I'm not telling this. This is by the syllabus. Don't believe me, believe the syllabus. Describe the formation of ethanoic acid by oxidation of ethanol. Look, with acidified aqueous potassium manganate, okay? This is with acidified aqueous potassium manganate, and by bacterial oxidation during vinegar production. So, in order to produce vinegar, you had to write about the bacterial oxidation. Many people might have written about the adding acidified aqueous potassium manganate. I don't know if the examiner is gonna, think about it as correct or not. I personally don't know this. If examiner is gonna, take this acidified aqueous potassium manganate correct or not. But the correct way in the syllabus was that you had to produce vinegar, this vinegar production by bacterial oxidation. Okay, so I guess that was, completely an ignorance of the syllabus that caused problem in this question. Okay, so describe the manufacture of vinegar. You just had to do bacterial oxidation, and you could write an equation for it, and you just had to oxidize your ethanol in air by using bacteria. Okay, so that was simple. Okay, butanoic acid and propanoic acid are two other carboxylic acids. State the molecular formula of butanoic acid. Molecular formula is going to be C4H8 and O2. I guess that's simple. If you cannot do it this way, you can just draw it that you draw 4 carbons, then you do like this, then you do like this, and H, 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 H. Count all that, and you put it like this. Okay, so you just had to write the molecular formula, which is this. Okay. Draw the displaced formula of propanoic acid. I know this is damn confusing. I don't know why examiner is trying to confuse you by first asking for the molecular formula of butanoic acid and then asking for the displaced formula of propanoic acid. So I know examiner is trying to be a bit like confusing, trying to confuse you, but you had to be careful doing your paper with open eyes and reading all this. I know, while doing your exam, we are a bit like, tensed and not in our like proper senses, but still in order to do this exam you had to be careful. So draw the displaced formula of propanoic acid. It's going to be 3 carbons. Because it's displayed, we have to display each and every bond. Even if you've written like this double bond OH like this, that's wrong. This is not displayed formula. For displayed formula, you have to show this OH bond. You have to open this OH bond like this. Okay, so you do this, and I guess that's gonna be your propanoic acid. Okay, solid sodium carbonate is added to dilute propanoic acid. Predict an observation for this reaction. Okay, what's basically happening? You're adding a carbonate into an acid, so you know that your acid plus carbonate, what's gonna happen? It's gonna give you a gas, which is gonna be carbon dioxide gas, plus water plus a salt. Okay, so what is going to be the observation? It's going to be fizzing of the carbon dioxide gas. It's going to be effervescence. Okay, fizzing, effervescence, bubbling is going to be considered one thing. But if you are good enough, since it's for 1 mark, it's going to give you your mark. But you can also write that this solid sodium carbonate is going to disappear or decrease in mass, because we don't know either acid is in excess or not. So let's not take risk by writing this. but you could also write that it's gonna decrease in mass, or it's gonna reduce, or it's gonna disappear. But this is the best one because that's 100% confirmed. Okay. Aqueous sodium hydroxide is added to dilute butanoic acid. Okay, what's basically happening? We are adding an alkali to an acid. Okay, adding an alkali to an acid. State the name of the products of this reaction. Let's do this reaction. So we have a sodium hydroxide. So sodium hydroxide, let's not do it this way. Let's do it with the formula NaOH plus butanoic acid, which is going to be C4H8O2, is going to form Na C4H8O2, not O2. I guess I have to write it in an open way so that it's easy for you guys to understand, because that's going to confuse you. So it's going to be C3H7COOH. Okay, that's another way of writing butanoic acid. So it's going to be, so it's going to form sodium butanoate, which is going to look something like this: CH3COO, and you have then your sodium. Okay, so that's sodium butanoate. What I'm doing, C3H7, sorry, plus water, H2O water. Okay, so these are the two products that's going to be formed, because you know that whenever we react an alkali with an acid, we form salt and water. So the products are going to be salt and water. The salt is going to be sodium butanoate. Sodium, we have to write the names, not the formulas. Butanoate plus and water. But since I guess it's a 1 mark question, so you might get marked for writing only sodium butanoate, but I'm not sure, because the products are two. Let's move on. Okay, the combustion of fossil fuels is used in some power stations. Okay, some power stations use diesel oil as a fuel. One compound in the diesel oil has the formula C12H26. Okay, construct the simple equation to show the complete combustion. Okay, since it's complete combustion, that means that we cannot form carbon monoxide. We have to form carbon dioxide of C12 and H26. So how to do combustion? So for combustion, we need to first take C12, H26. We have to add oxygen to it, okay? And now we're going to form carbon dioxide and water. To balance it out, we have to take 12 carbons over here, and because it's 26, we have to take 13 waters over here, half of 26. That's simple balancing, I guess. That's going to be 24 plus 13. So what comes out? 24 plus 13, and that gives me 37. So because I'm getting 37, and 37 is not a multiple of 2, is it? Let's check. It should not be, because 7 is not a yeah, it's not. So you write 37 by 2 over here. Okay, half of 37, or you can write 18.5. Okay, you can write 18.5. So let's write 18.5 for your easiness. Sorry for this thing. Okay, I guess this is a bit like, okay, don't worry, we just gonna do it again. C12H26 plus O2, that's gonna give me carbon dioxide plus water, and I have my 13 waters and 12 carbon dioxide and 18.5 oxygens. Now what's gonna happen, because I cannot take this number, this 18.5, I cannot write. So what I'm gonna do, I'm gonna multiply this entire equation by 2, and when I multiply this entire equation by 2, I'm gonna get a 2 over here, okay, and I don't know why it's not erasing. I'm gonna get a 37 over here, because I'm gonna get a 24 over here, and a 26 over here. So that's gonna be the complete balanced equation. Okay, I hope you get it. Okay, the complete combustion of C12H26 produces air pollutant. State one adverse effect of this pollutant. Okay, so many people might think that the pollutant is going to be carbon monoxide, but I've just told you that it's a complete combustion. So don't think carbon monoxide is going to be produced. Though the air pollutant is going to be in fact carbon dioxide. And what does carbon dioxide cause? State one adverse effect of this air pollutant. It's going to be for sure global warming, and you can write leading to climate change. So global warming leading to a climate change. That's going to be the adverse effect. Okay. Explain how diesel oil is separated from petroleum. Okay. So in order to gain these 3 marks, you had to explain how diesel oil is going to be separated from petroleum. So let's just draw to figure it out. We had to write about fractional distillation. First, what's going to happen? What are we first do to petroleum? To do fractional distillation, first you have to turn it into a vapor. Let me show you guys a picture of this if I could. Okay, fractional distillation of petroleum. Fractional distillation of petroleum. Okay, first we have to turn it into a vapor. Look at an image. Look. So copy, and I wish that it could be pasted over here. Paste. Okay, we have it. So what's first gonna happen is that we are gonna turn this crude oil is the same as petroleum. So first thing that we're gonna do is we're gonna turn this crude oil or the petroleum into a vapor. So we're gonna heat the oil in the furnace. So the first thing that we're gonna do, the first mark is gonna be for turning it into a vapor. Turning it into vapor. Okay. Then the second mark is gonna be that we're gonna pass it from a fractionating column. This thing is called a fractionating column. So the second thing is gonna be passing it through a fractionating column. Okay, column. After we passed it through the fractionating column, the last thing is gonna be to collect the diesel at this point. Okay, I don't think you had to mention the chain length or the temperature. That's not included. You just had to write that it's gonna condense. The vapor is gonna condense. Okay, it's gonna condense, and then you have your diesel fraction. Okay, so simple. You're gonna just heat it. It's gonna go inside. This heated is gonna move up. As it moves up at different temperatures, the lower fractions are going to be collected at the top, and the heavier fractions are going to be collected at the bottom. And as you move up, the temperature basically decreases, and all the fractions, what's going to happen, they're going to condense. So I guess that's all you have to write. It condenses and it forms diesel. Okay, and it would be good if you could write that it's going to be formed like not very above. It's going to be almost in the middle and not very below, but I don't think that's very necessary. You just had to write about the general things. Okay, so moving on. Sulfur dioxide is removed from the emissions of the power stations using calcium carbonate. Okay, that's flue gas desulfurization that you do with sulfur dioxide. State 1 adverse effects of sulfur dioxide as an air pollutant. Oxides of sulfur and oxides of nitrogen, they cause your acid rain. Okay. 1 mole of sulfur dioxide reacts with 1 mole of calcium carbonate to make 1 mole of carbon dioxide and only one other product. Suggest the formula of this product. Try to understand this question, though it's of 1 mark, but it requires understanding. Okay, what's happening is you have 1 mole of sulfur dioxide. So 1 mole of sulfur dioxide reacts with 1 mole of calcium carbonate plus CaCO3. Okay, that's 1 mole of calcium carbonate. To make 1 mole, okay, there's going to be 1 mole of carbon dioxide and one other product. Okay, whatever this product is, we don't know. Okay, what do we know? Right over here, we know that according to the conservation of the products and whatever is going to be formed over here is going to balance the equation on the other side. Okay, we have already used we had 1 carbon on this other side. We've used it. Okay, we've used the 1 carbon we had. The second thing that we had was oxygen. Okay, we have, out of how many oxygens I had 5 oxygen, 2 from here and 3 from here. Out of these 5 oxygens, I've used 2 in making carbon dioxide. How many I've left? I've left with 3. Okay, I am left with 3 oxygens. So that I know that I'm left with 3 oxygens. So okay, I have 3 O's because I've used one. I know that I'm left with 3 O's. I'm left with a calcium and S. Ca CaSO3, that's going to be formed. Look, CaSO3. That's simple. That's simple and easy. Why it's simple and easy? Because you just had to look what you're left with. After using 1 carbon and 2 oxygens, what I'm left with, because at 5 I've used 2, so I'm left with 3 oxygens. Okay, my carbon has been used, my oxygens are now finished, I am just left with calcium and sulfur. So 3 oxygens, calcium and sulfur. How to combine them? CaSO3. So that's gonna be your final answer. Okay, state and explain the effect of increasing the temperature on the rate of this reaction. I don't know, this question, even needs an explanation. Increasing temperature would basically increase the kinetic energy of the particles, and when they have greater kinetic energy, they are gonna collide more frequently, which is gonna increase the frequency of effective collisions. And one other thing is gonna be that when you increase the temperature, what happens, a greater proportion or percentage or number of particles have energy equal to or greater than activation energy. So it's going to be a greater number of particles have energy equal to or greater than activation energy. So activation energy, so that's all with temperature. Okay, it increases the kinetic energy and increases the number of particles with the activation energy, and hence there are more collisions and there are more effective collisions. Okay, so lumps of calcium carbonate are used instead of calcium carbonate powder. Okay, when you're using lumps, that means you're using large pieces. When you're using powder, that means you're using small pieces, and when you have small pieces, that means you have a greater surface area, so you have a greater rate. And when you're using lumps, that means your surface area decreased, your rate will decrease. State and explain the effect of this change on the rate of the reaction. Okay, so what's going to happen to the rate is gonna decrease. So first effect is gonna be rate decreases. Why? Because surface area decreases. Why? And what's gonna happen when surface area decreases? When the surface area decreases, there are gonna be less collisions between the reactant particles, less effective collisions. Okay, less the reactant particle exposed. So that's all with it. Okay, you can just read it from here. Okay, greater particle size, less surface area, and less chances of successful collision, hence rate decreases. Okay, so that's all for it. Because of less collisions, your rate is simply gonna decrease. That's all, and we're done with this. Okay, bromine is in group 7 of the periodic table. The melting point of bromine is -7 and the boiling point is 59. Explain why bromine is solid at -50. Why? Because look, this is your temperature line. Okay, this is your temperature line. Over here you have a 7 degrees Celsius. Okay, and -7. Okay, you have -7 degree, and as you increase the temperature, you're gonna approach 59. Okay, degrees Celsius. And in negative temperature, a -50 means that temperature is below -7, because in negative numbers you count it backwardly, so it's going to be a -50 right here. Okay, so at -7 is the melting point. Okay, it's the melting point, so this is the melting point, and 59 is the boiling point. At melting point, it's gonna turn, okay, over here now this is bromine is traveling, it is a solid, okay, and at melting point the solid is gonna turn into a liquid. Okay, and this liquid travels, and at boiling point this liquid is gonna turn into a gas. So at -50, it's less than the melting point, so that's why it's going to be a solid, because at melting point it's going to turn into a liquid. Before melting point it has to be a solid, and -50 is before melting point. So we're going to write that that -50 degrees Celsius is less than the melting point, which is -7 degrees Celsius. Okay, -7 degrees Celsius. That's all. You just have to realize that -50 is a lesser number. Describe the arrangement and motion of bromine molecules at -50. Arrangement and motion. Okay, at -50, since it's a solid, so at -50 arrangement is going to be fixed arrangement, lattice arrangement, regular arrangement, okay, and motion is going to be vibrate about their fixed positions. So arrangement is going to be regular, you can write lattice, then for motion you can write vibrate about their fixed positions. That's what solid do. They cannot move freely, so it's vibrate about fixed positions. That's all that these particles can do, okay, because they're solid, they're packed in a lattice. So that's gonna be all. Okay, a sample of bromine liquid contains 2.408 into 10 raised to power 25 molecules. 1 mole of bromine liquid contains these many molecules. Calculate the mass of the sample of bromine. Okay, calculate the mass of the sample of bromine molecules and calculate the mass of the sample of bromine liquid. Okay, let's try to digest this question. It's easy, but it's given in a bit trickier form. Okay, you have bromine liquid and it contains these many molecules. Molecules mean that one molecule mean that this is one molecule. Okay, it means two atoms covalently bonded. Next part is that 1 mole of bromine contains these many molecules. That's the Avogadro's constant that they've given you. Calculate the mass of the sample of the sample of the bromine liquid. Okay, first thing that you had to realize was that you had to, in order to calculate mass, what is the formula for mass? Okay, just don't get confused and write down the formula for mass. Mass equals to your moles times your MR. Okay, moles times your MR. Okay, but you don't have your moles. You have your MR, but you don't have your moles. Okay, MR for bromine liquid. Since it's liquid, it's molecule. So what's going to be the MR? The MR of one bromine. Okay, see this. I know many people if you made this mistake. MR of one bromine is 80. Okay, not MR, AR. It's going to be atomic mass. Okay, for one bromine is 80, but they're talking about bromine molecules. Bromine molecules mean Br2. Br2 means 80 times 2, which is going to be 160. So the MR is not 80, it's 160. All of you, those have done this mistake, you had to realize that bromine exists in molecular form. They're talking about molecules. So MR is going to be 160. Okay, so the MR is going to be 160, but moles we don't have. So how are we going to get moles? It's simple. You just had to apply the formula for moles. Moles equal to number of particles, which is this 2.408 into 10 raised to power 25 upon 6.02 into 10 raised to power 23. You just have to do this. This is how you're going to get the moles, because these are the number of particles and you divide them by the Avogadro's constant. After dividing this, you're going to get this, which is 40.133 moles, and when you multiply these moles, which are 40.133 by 160, 160 is the MR. You're going to get, what are you going to get? 40.133 multiplied by 160. Let's do it. Okay, 40.133 multiplied by 160, that's going to give me this value, which I'm going to copy, and I am going to paste it right here. So that's my answer. Okay, so done with this one. Okay. The next question says the ionic equation shows the reaction of bromine with warm concentrated aqueous sodium hydroxide. Okay, state the oxidation number of bromine and Br2 and -1. I guess that's the easiest question in the entire paper. Br -1 is going to be a -1, and over here it's going to be a 0. Okay, during the reaction bromine is reduced. Explain why using ideas about electrons. We have to talk about electron transfer or gain. It's reduced. Reduction means a gain of electrons. So we are going to write that bromine gained 1 electron to form bromide ions. Okay, I guess that's simple enough that it just gains electron to form bromide ions. Okay, so over here you have bromine that's gaining electron to form your bromide ions. So now next thing, bromine reacts with hydrogen in a closed system to form an equilibrium mixture. The forward reaction releases thermal energy into the surroundings. Okay, that's a very important statement, that the forward reaction releases thermal energy. That means that forward reaction is going to be exo. And when we know forward is exo, we already know that backward is going to be endo. That's really helpful. Okay, the temperature of the equilibrium mixture is increased. That means when we increase the temperature, the reaction moves towards the endo side, so it's going to move backwards. The pressure remains constant. State and explain what happens to the position of the equilibrium. It's going to move backwards, so it shifts to your left side. Okay, it shifts towards the left, or you can say backwards. Why backwards? Because when you increase temperature, what's going to happen? The endothermic reaction is going to occur, and the explanation is going to be that backward reaction is endothermic, or you can write that forward reaction is exothermic. Forward reaction is exothermic. That is why this is happening. Okay, the pressure of the equilibrium mixture is increased. The temperature remains constant. State and explain what happens to the position of the equilibrium. Okay, now what's happening is that you're increasing the pressure. Okay, for pressure, you need to calculate the moles. Okay, for pressure, you need to calculate the moles. How many moles do you have on this side? This is 1 mole, this is 1 mole. So a total of 2 moles. And over here as well, a total of 2 moles. So when you have equal number of moles on both sides, pressure has no effect. Okay, since they're all gases, that means that pressure has to affect them. So now we calculate the moles, and we calculated out that we have equal number of moles on both sides, so there's going to be no effect of the pressure. So state and what happens to the position of the equilibrium, we're going to write that no change or no effect. The explanation is going to be equal number of gaseous moles on both sides of the equation. Okay, on both sides of the equilibrium. When you have equal number of moles, your pressure is not going to affect the equilibrium. Okay, a bromide of phosphorus contains 7.2% phosphorus biomass. Calculate the empirical formula of this bromide. Okay, if 7.2% is phosphorus, how much is going to be bromide? Obviously, phosphorus ratio bromide. If 7.2 is phosphorus, then 100 minus, because the total percentage is obviously going to be 100, so 100 minus 7.2 is going to give me the percentage for bromide. So 100 minus 7.2, which gives me a 92.8. So my bromide is going to be 92.8. And now to calculate the empirical formula of this bromide, I just have to divide it by their masses. Phosphorus is 31, I guess. Bromine is 80. Let's check. 7.2 divided by 31. Okay, 7.2 divided by 31, that gives me this number. Copy, paste. Okay, next, 92.8 divided by 80. 92.8 divided by 80. 1.16. Okay, so I have 1.16, and where did my earlier number went? Okay, let's do it again. 7.2 divided by 31. Okay, 0.23. So 0.23. Now I have to divide both of them by the smallest number. I guess 0.23 is the smaller one, so let's divide both by 0.23. Over here I get 1, and over here I get 1.16. 1.16 divided by 0.23, and this gives me a 5. Okay, this gives me a 5. So I get a 5 over here. So it is going to be PBr5. Okay, so I hope you get this. It's going to be PBr5. Okay, PBr5. Okay, so that was simple. Let's move on. Iron is used to make stainless steel. Okay, stainless steel is used to make cutlery because of its resistance to rusting. Give other reason why stainless steel is used to make cutlery. That was easy because it's clearly mentioned in the syllabus. If you are, lacking syllabus, you've not studied it properly, then you might be confused. But if you are good to go with the syllabus, describe the use of alloys in terms of their physical properties, including stainless steel and cutlery because of its hardness and resistance to rusting. They've mentioned resistance to rusting over here, and you had to mention hardness over here. So it was hardness. Okay. Stainless steel is an alloy. Give the meaning of the term alloy. Again, you just had to consult the syllabus. An alloy is a mixture of metal with other elements. Okay. Give 2 ways galvanizing iron nails with zinc prevents rusting. What are the 2 ways? Okay, what's basically happening? You have this iron, just think about it. This is your iron. You galvanize it and you coat it with a layer of zinc. Okay, let zinc be with gray. Okay, so this is your layer of zinc that you've coated over iron. So this is this is gonna be your zinc. Now what's gonna happen is that since this zinc is more reactive than iron, so it's gonna corrode instead of iron. Okay, so the first thing that zinc is gonna give iron is sacrificial protection. Okay, so first thing is gonna be sacrificial protection. Because we had to mention 2 ways, it's clearly mentioned in the syllabus that describe the 2 ways zinc in galvanizing is an example of a barrier method and sacrificial protection. So these were the 2 ways. So first is going to be sacrificial protection, and the second is going to be barrier method. What do I mean by a barrier method? A barrier method means that zinc forms, firstly, zinc is going to provide sacrificial protection by corroding instead of iron, and by providing a barrier method, what zinc is going to do is it's going to form this layer over iron, and what this layer is going to do, it's not going to allow air and water to reach the surface of iron to corrode it. A barrier, you form a barrier over iron. Okay, you have shielded iron. Okay, firstly by this thing, and secondly by coating it with such a thing that does not allow air, water to reach its surface, thus preventing rusting. So these were the 2 methods that you had to write, and these were 3 marks. So you just could explain with method that barrier method prevents air and water to reach the surface, and sacrificial protection means that since zinc is more reactive, it has a greater tendency to form positive ions. It's going to react instead of iron. So that was simple. Okay, next thing is going to be iron reacts with hot dilute sulfuric acid to form hydrogen and aqueous iron 3 sulfate as the only products. Okay, this was my favorite question in the entire paper. Why? Because it requires an equation. Construct a simple equation for this reaction. You have everything that you need to make this equation. You have your reactant, which is going to be iron, that's going to react with sulfuric acid to form, the products are going to be simple, hydrogen and aqueous iron 3 sulfate. So you just had to make, you had to take iron, and in iron you had to add sulfuric acid, which is H2SO4, and you had to make hydrogen gas, which is going to be H2 plus iron 3 sulfate. Okay, I know this must be confusing for you guys to write the formula of iron 3 sulfate. Iron is Fe2 plus, okay, and sulfate is SO4. Since it's 3 plus, so it's going to be a 3 plus. Okay, so over here let's write a 3 plus. Sulfate is SO4 2 negative, so this is going to come here, this is going to come here, it is going to become Fe2 SO4 and 3. So that was the way you had to write it over here. Okay, I know many of you must have done this wrong, because it is Fe2 SO4 and 3. So that's how you write iron sulfate. And now to balance it out, you had to write A3 over here, and to balance this out, you had to write A3 over here and A2 over here. Okay, so that was how you had to write the equation, and the 2 mark was 1 for writing the equation and 1 for balancing it out. Okay, so next question. Okay, figure 8.1 shows the displayed formula of a compound A. Compound A, I can see this acid. What do you guys think? Is this the acid functional group? A second. Right now your chemistry is being tested. Is this the acid functional group? How many of you think this is? If you think this is, you need to work on the chemistry, because this is not. This is alcohol functional group, but this is not acid functional group. Why? Because acid functional groups look something like this. C, double bond O, O and H. Okay, not like this. This is not the acid functional group. Okay, next thing is we have a alcohol functional group over here, OH group. Okay, compound A is both a saturated alcohol and a saturated ester. Why is it an ester? What do you guys think? Because we have an ester linkage over here. Okay, explain why compound A is saturated. Saturated means all carbon bonds are single. देखें, अगर आप, if you guys think that saturation just means that all bonds are single, that's incorrect. All carbon bonds are single because all bonds are not single. Over here you have a carbon oxygen double bond, so according to you it must be unsaturated, but it's not, because what, for saturation we look at carbon bonds, not carbon oxygen, not carbon hydrogen, any bond with carbon. What our focus is carbon bond. So because it's saturated, why? Because all carbon bonds, because all carbon bonds are single. Okay, carbon bonds are single. Okay, explain why compound A is an alcohol. You know, there's a hydroxyl functional group, or you can write, and there is a hydroxyl functional group. You call it a hydroxyl functional group, that's a fancy word, functional group, or you can say there is an alcohol functional group. Okay, explain why compound A is an ester. Why is it an ester? You see an ester linkage over here because it has an ester linkage, or you can write an ester functional group because it has an ester functional group. Okay, I guess these were free marks. Figure 8.2 shows compound B. Compound B is definitely an alcohol because it has correct alcohol functional group and carboxylic functional group. Okay, this one is alcohol and this one is carboxylic. This one is carboxylic functional group and this one right here is your alcohol functional group. Explain why compound A and B are a pair of structural isomers. What are structural isomers? Structural isomers mean that I didn't even see at their molecular or any kind of formula. I just heard that they're structural isomers. I knew why. Structural isomers mean that you have the same molecular formula but a different structural formula. A different structural formula. Okay? So that was all I knew about structural isomers. Same molecular formula, I'm sure I didn't check it, but because they've told it, I'm sure these two guys must have the same structural, same molecular formula and different structural formula. Okay. The displayed formula of compound C is shown. This is compound C. Compound C is an ester. Okay, we know it. Well, how do we know it? Because of this linkage. Okay. Compound C is made by the reaction of an alcohol with a carboxylic acid in the presence of a catalyst. State the name of the type of the catalyst used in this reaction. Okay, this might confuse you guys, but it's clearly stated in the syllabus that for esterification you need a acid. Okay, you need an acid catalyst. Okay, you need an acid catalyst. And if you want to be really specific, you should know that the catalyst that you use, okay, that's gonna be, I don't know why it's erasing, it's gonna be sulfuric acid. And many of you who might not believe that this is part of the syllabus, they must check out the syllabus. It's clearly mentioned that you use an acid catalyst. Okay, state the name and draw the displayed formula of the alcohol used in this reaction. To find out the alcohol, we're going to cut it from here. Okay, we cut it from here. This part is the acid part, this part is the alcohol part. So what kind of alcohol with 3 carbon? What kind of alcohol are you going to use? You're going to use propanol because that has 3 carbons. So the name of the alcohol is going to be your propanol, and the displayed formula for propanol is going to be 3 carbons and a O, and you had to show this OH bond. That was a compulsion. You could just not write OH, that's going to be incorrect. And I guess this is the displayed formula of propanol. Okay. Now, figure 8.4 shows 2 monomers that react to make a condensation polymer. Okay, you have monomer D, you have monomer E. This is diol because it has 2 alcohols functional group. This is dicarboxylic because it has 2 carboxylic functional groups. Okay, draw the structure of 1 repeat unit of this condensation polymer. I just have to draw 1 repeat unit. Okay, how am I going to make a repeat unit? What I'm going to do, I'm simply going to take H from here and OH from here. I just cross it out on the paper, and now I draw whatever is left. Okay, this part is left. Okay, I have this part and I have to join it with this part. Okay, let's do it. Okay, firstly there's going to be an O, then there's going to be a C. I'm just copying it. okay? There's going to be an H, then a C, an H, and now I again have an O. I'm going to join it with my other thing, which is going to be this. Then 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, and 5 carbons. 1, 2, 3, 4, 5. A double bond over here and extension from here, okay? Extension from here because I've cut the OH. And now I just have to add my H. And I am done with my repeat unit, okay? That was all I had to do. If you want to enclose it in brackets like this, you can do it. You can write an N over here, whatever you want, but this is the one repeat unit, okay? Next question states that an equal number of moles of monomers D and E, okay, that's interesting, D and E are reacted to make a condensation polymer, okay? Equal, now let's erase this thing, okay. What did I basically cut out from here? I cut out this H and OH. Why did I just cut it out? Because I had to form water. Whenever condensation polymerization happens, you form a polymer and you also form a water, okay? So they say that you have equal mass of this and this, equal moles of this and this, reactor to make the condensation polymer. The total mass of the monomers D and E is 80 grams. There is 100% yield. Explain why the mass of the condensation polymer is less than 80 grams. Because if you're taking 80 grams of the monomers and your yield is 100%, that means the 80 grams of it should convert into product. So why is it not 80? Because you had to realize that the only thing that you're forming is not the polymer. You're also forming water, and water also is going to have some mass. That is why if you combine these two, you are not only going to form 80 grams of this. Some grams are going to be used to form this water. So the answer is going to be that water is also formed, or you can write that water formed also has mass, and that's all. Okay, so we're done with this paper. I hope you liked it, and do consider to subscribe the channel and like the video. That's going to mean a lot.